Guys, in this video we will discuss about how to find the maxima and minima of a multivariable function. So here we consider a multivariable function z is equal to f of xy, and here now I will describe you that how to find the maxima and minima of a multivariable function, and here are the procedures. First we have to find here the del z del x and del z del y. And next, we have to solve the simultaneous equation like del z del x is equal to 0 and del z del y is equal to 0. And after solving this, we will get some points, that is like x1, y1, x2, y2 and so on. And these points x1, y1, x2, y2 are known as the stationary points. And then what we have to do? Next, we have to find the del 2z del x2, del 2z del x del y and del 2z del y2, which is also known as where del 2z del x2 is defined by r, del 2z del xy is defined by s, and del 2z del y2 is defined by t. So now these are the basic that we have to first done. We have to find first all of this, and next we have to calculate the rt minus a square, where as first we define here what is r, what is t and what is s. And if r is greater than 0 at a point x1, y1, then we say that the function z is equal to f of xy has minimum at the point x1, y1. And the next, if rt minus a square is greater than 0 and r less than 0, then we can say at a point x1, y1, z is equal to, suppose if rt minus a square is greater than 0 and r less than 0, at a point x1, y1, then z is equal to f of xy has maximum at x1, y1. And number 3, if rt minus a square is less than 0 at a point x1, y1, then we say that the function z has no maxima and no minima, and the points x1, y1 are known as the saddle points. And if rt minus a square is equal to 0, then we have to show, or we can say that the further investigation is needed. So now these are the basic rules to find the maxima and minima of a bivariate function. So now we will discuss one problem, that how can we find a maxima and minima. So here we consider one function, that is z is equal to that is f of xy is equal to x cube plus y cube minus 63x plus y plus 12xy. So first we have to find here del f del x and del f del y. So if we partially differentiate with respect to x and with respect to y, we get 3x square minus 63 plus 12y, and del f del y is equal to 3y square minus 63 plus 12x. And for calculation, at first I also find the del 2f del x2, that is r, that is the 6x, and del 2f del y2, that is t, is equal to 6y, and also del 2f del x del y is equal to 12, which is s. And see here that here we can rename the del z del x by f suffix x and del z del y is by fy, and also del 2z del x2 can be defined by fxx, del 2z del xy is fxy, and del 2z del y2 is fyy. All are same. So now we have to find the del z del x is, and see here now that del f del x is equal to 0 imply x square plus 4y minus 21 is equal to 0, and del f del y is equal to 0 implies y square plus 4x minus 21 is equal to 0. We just rename it by 1 and 2. So now see here we have to find the value of x and y. So if we find if we do here that 1 minus 2, we get x square minus y square plus 4 of y minus x is equal to 0. And from here we can say that we get x plus y into x minus y minus 4 into x minus y, and from here we get x minus y into x plus y minus 4. So from here we can write that either x is equal to y or x plus y minus 4 is equal to 0. So now we consider the points x is equal to y. So if we take x is equal to y, then if we put x is equal to y in 1, then what we get, that x square plus 4x minus 21 is equal to 0, and after the middle term factor, we will get the value of x is minus 7 and 3. And since the condition is x equal to 3, x is equal to y, so when x is equal to minus 7, we can say y is equal to minus 7, and when x is equal to 3, we can say y is equal to 3. So now these are the one type of two stationary points, that is minus 7, and 3 and 3. So now we will check for the point x plus y minus 4 is equal to 0. So from here we get y is equal to 4 minus x, and if we put this value in 1, y is equal to 4 minus x, we get x square plus 4 into 4 minus x minus 21 is equal to 0, and from here we get x square minus 4x minus 5 is equal to 0. And after simplifying, we will get these 2 points, that is x equal to 5 and minus 1. And when x is equal to 5, if we put the value of x in this equation, we will get y is equal to minus 1, and if we put x is equal to minus 1 in this equation, we will get y is equal to 5. So now here we get 4 points, these 4 stationary points, and the stationary points are minus 7, minus 7, 3, 3, 5, minus 1, and minus 1, 5 are the stationary points. So now we have to check the RT minus A square, that is RT minus A square mean we can say that the value of R is 6x, value of T is 6y, and S is 12. So if we put all those value, we get 36xy minus 144, and whereas R is equal to 6x. So now if we put the point in this expression RT minus A square, minus 7 and minus 7, we will get 36 into minus 7 into minus 7 minus 144, which is greater than 0, and whereas R is equal to 6x, we get 6 into minus 7, which defines this R is less than 0. So we can say that the minus at the point minus 7, minus 7, the function f as maximum. And similarly now if we put the point 3, 3 in the equation RT minus A square, we get the 36 into 3 into 3 minus 144, which is greater than 0, and from the relation R is equal to 6x, we get that is 18, that is also greater than 0. So now we can say that at 3, 3, the function f is minimum. And now if we put the point 5, minus 1 in the equation RT minus A square, and if we calculate, we get that this is less than 0, and also if we put minus 1, 5, that is RT minus A square is also less than 0. Since RT minus A square less than 0 implies that there is no maxima, no minima, and the points are the saddle points. So here you can say that the 5, minus 1 and minus 1, 5 are the saddle points. And now we find that the minus 7 and minus 7, the function gives the maximum, and at the point 3, 3, at the point 3, 3, the function gives the minimum. At the point 3, 3, the function gives the minimum, and if we put the points, we can get the maximum and minimum, and you can check that the maximum value at the point minus 7 is 784, and the point 3, 3, the minimum value is minus 216. So I hope you understand. So thank you.